Hello everyone and welcome back to our Java programming tutorial series. I am so excited to guide you through another important topic today, the Java optional class. Have you ever encountered the dreaded null pointer exception? It is one of the most common and frustrating errors in Java programming, often referred to as the billion-dollar mistake. Well, the Java optional class, introduced in Java 8, is here to help us tackle this problem gracefully and write cleaner, more robust code. In this 5-minute animated whiteboard tutorial, we will explore what the optional class is, why it is so useful, how to create and use optional objects, and some best practices to avoid common pitfalls. Get ready to enhance your Java skills and make your code more resilient. Let us begin this exciting journey. Alright, let us dive deep into the problem that optional aims to solve, the infamous null pointer exception. Imagine you have a method that might return a value, but sometimes it might return null if a value is not found or applicable. If you then try to call a method on that null reference, boom, you get a null pointer exception and your program crashes. Traditionally, we would add if object is equal to null, checks everywhere, which can make our code look cluttered and harder to read. For example, consider a user service that fetches a user by ID. If no user is found, it might return null. If another part of your code then tries to access user.getName without checking for null, your application will crash. This is a very common scenario in real-world applications, leading to unexpected behavior and bugs. The null pointer exception is a runtime error, meaning it is not caught by the compiler, making it tricky to detect until your program is actually running. This is precisely where the Java optional class comes to our rescue. Now, how does optional help us avoid these null pointer exceptions? The optional class is essentially a container object that may or may not contain a non-null value. Think of it like a box. The box either contains an item or it is empty. It never contains a null item. This makes the absence of a value explicit, forcing us to handle it. You can create an optional object in a few ways. Use optional.of_value if you are certain the value is non-null. If the value passed to of is null, it will throw a null pointer exception immediately, which is actually good because it tells you about the problem early. Use optional.ofNullable_value if the value might be null. This will create an empty optional if the value is null, or an optional containing the value if it is non-null. Finally, optional.empty creates an empty optional instance. Once you have an optional, you can check if it contains a value using isPresent, which returns true or false, or isEmpty, which is its opposite. This way, you are always aware if you are dealing with a present value or an absent one. Now that we know how to create an optional, let us explore how to safely extract values from it and handle cases where the value might be absent. The get method will return the value if present, but beware, if the optional is empty, get will throw a noSuchElement exception, which is similar to a null pointer exception but explicitly for optional. A safer approach is to use or-else, default value, which returns the contained value if it is present, otherwise, it returns the provided default value. This is incredibly useful for providing fallback options. Another powerful method is or-else get, supplier, which is similar to or else, but takes a supplier function to generate the default value only when needed, which can be more efficient for complex default object creations. For scenarios where you absolutely require a value and want to throw a specific exception if it is not present, or else throw is your friend. Additionally, if present, consumer allows you to execute a block of code only if a value is present, making your code very clean. These methods encourage a functional programming style, leading to more readable and expressive code compared to traditional null checks. While the optional class is a powerful tool, it is crucial to use it correctly to reap its benefits. Let us discuss some common mistakes and best practices. A common mistake is calling optional.get without first checking is present. This defeats the purpose of optional and can still lead to no such element exception. Another anti-pattern is using optional for method parameters or class fields. Optional is primarily designed as a return type for methods that may or may not have a result. Also, do not use optional.equals or optional.hashcode. For comparison, just use the contained value if present. Best practices include always returning optional from methods that might not have a result, using or else get, or else throw to handle the absence of a value gracefully. Embrace functional methods like map, filter, and flatMap to transform or chain operations on the contained value, making your code more concise and expressive. Remember, optional is not a replacement for every null check, but a tool for making the absence of a value explicit and handling it effectively. And that brings us to the end of our exploration of the Java optional class. Today, we learned how optional helps us combat the notorious null pointer exception by providing a clear way to represent the presence or absence of a value. We covered how to create optional instances using nullable, and empty. We also explored essential methods like isPresent, isEmpty, or else get, or else throw, and ifPresent for safely handling values. We also discussed common mistakes to avoid and embraced best practices for writing clean, robust, and functional Java code. The optional class is a fantastic addition to the Java ecosystem, promoting better design and reducing runtime errors. I highly encourage you to practice using optional in your own projects. Try refactoring some of your existing code to incorporate optional and experience its benefits firsthand. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming content. Keep coding, keep learning, and I will see you in the next video. Happy coding!